Welcome everyone to the fourth session of Linux from Scratch workshop. I'll just give a recap of the previous session. In the previous session, we learned about the file systems in Linux, like what is the slash root, what is slash dev slash etc, etc. And after that, we also saw the user managing the users and groups and the permissions, which was taken by Samrit and Sachit. Now let's take a look at the processes and packages. In this session, basically we'll learn how to manage processes, which is if you are coming from the Windows environment, we should be very much known about the task manager. If you want to kill a process, you want to end a task, anything. And in the Linux system, that's it's all about the process. So we'll learn about that. And also we'll see the packages, installing packages and removing packages. Basically in Windows, you can directly install a package like .exe file and then run it, then install it. But in Linux, you have a different process, which is like which differs from every distro to distro. So if you're using a common like a distro from a common family tree, you'll be using the same package manager. In Linux, we have something called as a package manager, which helps you to download, install packages and remove packages, and that will be taken by Samrit. So I will start with the processes here. So let's see what the process is. So at first, I will just tell you about processes. Process is actually related to is a operating system. Like it's there in every operating system. It's not specific to Linux only. So process is basically a program under execution. Like everything you do is actually in the background. It runs as a process. So if you write a C++ code or a Python code and you're running it, even if you're making while you're typing the code, it's actually a process running in the background, which is taking your input, which is doing appending to the file and then saving the file. That is also a process. And when you're compiling the process, when you're compiling a program using GCC or CLang, that is also being executed as a process in the background. So you can say process is the every command in the background which is taken, like everything you do in the GUI, like writing a file, saving a file, executing a file, etc., is done by the associated with the process with it in the background. So that is about process. And a job, if you talk about job is basically a collection of processes which are meant to perform a specific task. So for example, if you are running, maybe the job would be to run write a Python code. So all the processes associated with the job is like saving the file, writing, updating the file with your changes, whatever you're writing, compiling the file, and showing the output of the file. That are all the unique processes, and the collection of these processes is called as a job. So this is it for as of now, and you will learn in depth about it when you'll have the operating system course in your curriculum, which I will be having in the third semester only. So that is about processes, and as I said, even when you're clicking a button or opening folders, even opening terminal, opening apps, anything, it's all associated with the process background. So it's important to learn about it because you'll need to monitor them and you'll need to maybe kill them, or if a process runs unresponsive, like you can't kill them from the GUI button, then you need to go into this command and you'll need to kill that process, like how you do in the Windows in the task manager. So let's learn more about it. So every process has a process ID and a parent process ID. So if you say, even if you open this Chrome browser, it is a process. So I just say this, that the init process is the parent process of all processes in the Linux. So when you are starting your system, the init process, init stands for initialize. So that process starts for the first time, like it is the parent of all processes. Under this process only, you will have everything you do after that, like after turning your system, you'll open a Chrome tab, you will open a terminal, or you'll just listen to music, everything. That will be the children process of this init process. So, and that children process will also have children to it. For example, if you are opening a Chrome application, like this is a Chrome application you have opened, it is a process, and its parent process is the init process. And if you open a new tab here, so it will be a child process. The new tab will be a child process of this Chromium terminal, like a Chrome application. This is clear. So my point is that every process has a parent process ID and also has a unique process ID, which determines a specific unique number to identify it. So as I've talked about, init process is the first process of every process. And after that, how many, depending on your usage, you will like 4 from those parent to children processes. Don't worry if it's confusing as of now. We'll just see it in the terminal as well. You'll get a clear idea of it. And now let's look at the process states. So every process has something called as a life cycle. So basically, it starts from when you start a process, it's in a running state, and when it's completed, it goes to the completed state. So within that, anything can happen. Like there, out of like I have listed out 5 states which can happen in between the life cycle of a process. So let's look at that. So running state, the R state, R stands for running state. So whenever you start a process, it actually goes with this. Like this is the normal state of every process. Whenever you start a process, it should go in this running state or runnable state. And then coming to the sleeping state. Sleeping state is actually like how will you explain it? But I will give you an example. For example, you are typing a code in your terminal, and for some time I will show you. Just write it as file, and I am just typing random code, and for some time I have just waited. Like you can see the cursor is blinking here. So I am not doing anything. For example, I'll just rest here for 5 to 10 minutes. So what will happen is the process which is running in background for this saving or writing a file, it will go into the sleep state because it needs some resources. The resource is like your the user input. The user input will be your keyboard strokes, and that process needs that until you save the file. If I save the file, that process will be closed. But until and unless I'm writing the file, I have opened the file and I'm writing it. You can see the cursor is blinking here. And if you don't give any input, that means that this process which is running at the background is waiting for your response, and you're not giving it. So, for example, for a specific amount of time, for maybe 1 to 2 minutes, if it sees that there is no input from the user, it will go into the sleeping state. Hope it is clear. And then this the D state stands for uninterruptible sleeping state. In this state, actually, you can't even kill the process now. Like you can't, as the name suggests, uninterruptible. So you can't interrupt it. Basically, it waited for the user input for much amount of time, and the CPU could not provide the resource to that process. So it entered into this process, and unless and until it acquires that resource, it will not come out of this stage. So you cannot kill the process in this state, like the D state. So yeah, I was talking about uninterruptible sleeping state. So you can't kill the process in this state, and it waits until and unless the CPU provides it with this resource. So now coming to the T state, which is a soft state. So basically, this is when you maybe listening to music and you click on the pause button. So that process in the background goes to suspended state, like it's temporarily suspended. And when you click on the play button again, it starts again. So that is about it. When you this is temporarily, you're just resume. You're just putting the process into temporarily stop process, and you can resume the process easily from where you left. So this is nothing of a harmful state. You just need to avoid this state, the uninterruptible sleeping state. Now come to the zombie state. Now in this state, actually its parent process is on. So as I said, that every process has a parent process. So if you kill the parent process first without killing the child process, that child process will now be orphaned. So in this state, the process is called the zombie state, and in this situation, you can't do anything. Like the process can't continue, and it just like stops on that stage only. Now, only when you turn off the init process, like when you power off your computer, only then that process will be killed. Unless that, like until that time, your process will be in the zombie state. An example of this will be when you're opening your Chrome tab, like a Chrome session, and you're opening a new tab here. Now, without killing, like without closing this new tab, if you will just straightly turn off the Chrome tab, what will happen is this new tab's parent will like get killed. So the new tab's parent is this Chrome tab, right? This Home tab. And without killing this new tab first, you are just directly killing the Chromium application. So now this new tab process, which is the process which is associated with this new tab, will be in the zombie state, and it will only be killed only when you power off your machine. Only when you power off your machine, the init process will get turned off, and after that, it will kill this process. So hope this is clear, somewhat clear. And now let's look at process monitoring. So as I have said, that processes are important, and we looked at the stages. Now comes that how will you look at the processes. All right, so process monitoring in this section, you will learn that how to look at all the processes which are ongoing in this current system. So there are two commands. One is the htop command, and the other is the ps minus aux command. Like this is a flag which specifies that, which tells that you need to tells the command that you need to show all the processes which are running, regardless of their states, whether it's in the sleeping state or it's in the zombie state or it's healthily running, you need to show all the processes. So this is for this flag. And htop is a bit, I will say that this is a better command because it refreshes your output. It shows them in a continuous manner. And like this is a static output. The ps minus aux command is a static output, whereas the htop command is a like a responsive output. We just see that in this. So first, you can open the terminal if you want to. If you want to look at all the processes and manage them. So first of all, let's type the ps minus aux command. Let's see what it gives. Yeah. Now just clear screen once and again ps minus aux. All right. Now it's better. You can see this header shows for the users. So it shows that which user has created this process. So there are many processes which is created by the root user. You can see. And there is some processes also created by the system D, which is basically a package. So a package can also create a process. And similarly, you can see color D, R ticket. Then comes the local user, which is me, Dhabaleshwar. And I have this actually the local user starts all the process that you do in the system. For example, what I did was GNOME session binary. That stands for if you have run any command. So this process will be started because it's a binary command. And for monitor, if you are seeing anything on the monitor, this process will be started. Then again, the GNOME shell, as we have told, terminal is just a GUI of the shell. So when you're opening terminal, you're basically creating this process which is running on the background. And etc. We can see something like, should be Chromium. There should be something because I'm using Chrome. Let's see. Discord, yeah, Discord is also open on my system right now, so there is a process associated with it. Here is the Discord open, so there is a process associated with it. Similarly, Chromium, yeah, you can see. So whatever you are using, basically whatever apps you're using on the background, the process will be associated with it. You'll see here the process ID, which I was talking about. It starts from 1. So see, this is the init, which I was talking about. The init process is the first process which starts in computer. So that is always assigned the PID of 1, and it doesn't has the parent ID. It's the first process. So after that, you can see the list of all processes which are started in this order, and you can see the first few processes are always started by the root because our administrator first maybe creates the basic things which are needed, like it starts the monitor, it starts some system services which are needed every time you start a machine, etc. And after that, your user, whatever you do in your system, will get started as a process. So this was about the ps minus aux, but you can see it's static, like it has ended. It has a static output. It's refresh with every new process that you create. So for that we have this command called htop. Let's look at that. Yeah, here you see you can see the page is refreshing on its own. So it's very much more verbose output. So first let's talk about this. So you can see these are the number of CPUs in my computer. I have 4 CPUs, so it shows 0, 1, 2, 3, and shows the load on them. Like CPU 1 is taking currently 90% load, then 100. Okay, when I'm just 100, so you can see that is a load now 66. So that is about the CPUs, and this is the memory, the RAM you have, and currently how much RAM is being allocated. I've also created a swap partition, which is basically a virtual RAM, so it also shows that how much has been like taken into that. And currently it shows the number of tasks which are happening currently, which is 124, and 2 running currently. Load average. Load average is something like you can take to understand how your computer is performing. So you can see in the load average, you can see 3 numbers. One is 4.65, 4.36, 3.03. It keeps on changing, but what it is basically it shows the load on your computer 1 minute back, and then this shows the load on the computer 5 minutes back, and then it shows the load on the computer 15 minutes back. So 15 minutes back, I didn't have this meeting started, so there was less load, which is 2.99 or 3. Now 5 minutes back, I have been keeping talking about this session in the meeting, and it's also been recorded, so the load has increased. And 1 minute back, maybe something stopped, some processes are being stopped, so the load is being decreased. So using these 3 numbers, you can like understand how the computer is performing. Like 15 minutes back, it has better performance because it was like it has less load on the CPU, and now 5 minutes back, it has the highest load on the CPU. Currently, it has a lesser load than the highest load. And the uptime, this basically shows for how many hours your computer has been turned on. So currently, my computer has been turned on since 1 hour 51 minutes. So this was some basic information. After that, you can see here the PID, the process ID of every process, and you can see the command which invoked the process. Like Chromium, this is a command which I typed. Like I opened the Chrome tab, so basically the process got associated with it. Pulse audio basically stands for maybe I've connected my Bluetooth. You can see, so Pulse audio is used for that. So also started. Similarly, you can see all the list of all processes which are getting started and who is the owner of it. The user is half of the time it's me or half of the time it's root. And then the PRI, I have honestly no idea about it. I'll say what I have the idea. Yeah, this shows the CPU, how much percent the process is occupied on the CPU, how much RAM the process is occupying in the like in the RAM, how much memory is occupying in the RAM. Time is shows for how much time the process is running. You can see here maybe 12 seconds or something the process is running. So this shows that you can analyze the processes here. And yeah, the S. I was talking about the state, right? So this is the state. You can see it's been in the S state, so it's in the sleep state. If you see here, yeah, the S starts for the sleeping state. So it's currently waiting for the user to give some input, or it's waiting for a resources which the CPU has not been allocated to this process. So many processes are in the sleeping state here. I'll show you some process which is in the running state also. Mm, Yeah, you can see here the running state process. R starts for running. So Chromium is currently running. So you can see R against that. And R against this GNOME shell. Yeah, terminal is running. So you can see R against that. So similarly. So this was basically about the process monitoring. You can see all the processes here. And for example, one process goes unresponsive. Like it's not taking your input anymore. It has got stuck. So you can kill that process by using a command called as kill process. So basically we'll have to use this PID. For example, I want to, okay, I can't show you that because if I kill a process, maybe the recording will get stopped or the meeting, I will get kicked out of the meeting. So we don't want that. But for example, I'll just show you. For example, if you want to kill this process 5437, you have seen its PID. Now we'll quit out of it. To quit out of HTOP, we just need to press the Q icon. So sorry, the key Q in the keyboard. So after that, just clear the machine, and now we'll just use this kill all command. Or kill will also work, by the way. So kill all, and the PID which you need to provide is 537, which we saw. So if you provide this will kill this process regardless of whether it's unresponsive or it's working. It will just kill it. So I'll just, if you want to see the options in kill all, you can just do kill all. Yeah, this shows all the options you want to kill, and if you want to kill processes which are attached to a particular user, you can also do that. And the version, etc. So these are all the list. You can just do that. I've just showed you how to kill a process. You'll just do kill all, and you'll just do the process PID number 537 or whatever it is. You can get the PID number by using the stop command. So hope it's clear. Yeah, great. Now coming to the last part, and it's important also, background and foreground jobs. So foreground is generally the normal terminal which you are working with. So for example, you are working in this terminal, and this is your general foreground. Foreground signifies that you can work with one command at a time, only a single command at a time. But background, you can work with multiple commands at a time. So as the name suggests, what you will do in background is you will send some processes which are currently running in foreground, and you will send them to the background. You will tell them that yeah, you go on and execute on the background while I continue to work in foreground. So in background, you can work on multiple processes at a time. So for example, if you do, I'll just show you jobs. See these commands which have been listed here. The jobs command will show you. Second. Yeah, the jobs command will show you all the processes running in the background currently. As you see, it shows no output, so it tells that there is no process currently running in the background. So we can do that. For example, if you want to put a command to run in background, you will just type the command, and at the end you just need to append this ampersand character. So that this ampersand character tells that run this particular command in the background. Don't do it in the foreground. For foreground, for example, I just do sleep 1000. So it's just a command to tell that to stop this process for 1000 seconds. So I just do sleep 1000. You can see it's being running on the foreground. To exit out of it, you will just press Control C, and to run it in the background, you just append this sleep the command with a ampersand character. Now you'll see that this shows you this output. What it basically shows you, this is the PID of the process 9039, and the one shows you the index of the process. Now if you press the jobs command, you'll see that a process is running in the background which we have sent. This is the command which is running in the background, and this is the status of it, like it's running now, because it's working in the background, so it's running now. And this shows the one shows the index, and this plus shows that this is the current command which is being executed in the background. For example, if you have another command, sleep 1000, and you'll see it's been allocated in index number 2, and it has a process ID of 9035. Now if you press again jobs, you'll see that both are running, and the current, the latest one is this, the number 2 is the latest one, and minus shows that just the latest one. So 1 and 2. So similarly, you can just do any of the commands like cd slash etc slash just slash etc, and just append slash like the ampersand, and if you do that, you can see it's been associated with number 3 in the background. And if you again press job, you'll see it's listed, and here you'll see it's done, because it's like the cd slash etc command is a quick command, like it will be done in maybe say 1 second. So it's, you can see the status is already completed for that, and the other two processes are running because we have provided a sleep of 1000 seconds. So this is how you can push commands into the background, and to basically bring a command from the background to the foreground, we'll see like for example, this you want to bring this sleep 1000 ampersand command, which is running as number 2 from the background to the foreground. So you want to bring it to your terminal. What you will do is you will just use the FG command. FG stands for foreground, and then percentage sign and the number which is associated with it. So number 2 is associated, so you can press 2. Now you'll see that the command is being run in the foreground, like how you generally run commands, it is being run that way. And this is just wait for 1000 seconds, and then it will complete. If you don't want to like wait for 1000 seconds, you can press Ctrl C to quit this, like to end this process. Or if you want to again push this process from foreground to background, you can use Ctrl Z, as you have seen here. The push a job into background from foreground, use command Ctrl Z. So if I press Ctrl Z again here, you'll see it's been stopped as well as it's been pushed into the background. Now if I press jobs here, you'll see that the number 2, which was brought to foreground and again pushed to background, is now stopped, but it's in the background. So basically, if you need to start this command in the background, what you will do is use the BG command. So BG %2, just like how you used for the foreground FG, and now you'll just see, yeah, it's running. So if you do jobs now, you'll see both are running now. So hope it was clear. And basically you have to bring from foreground to background, you have to press Ctrl Z. To run a process in the background, you have to append it with ampersand character. And if you see a process is being stopped, or the stop state is basically this state which is talked about, this T, the process state T, it's basically the stop state. So if you want it from stop to running, then you can use the BG command with the job number. Then if you want to bring from the background to foreground, you can use FG command. Then to list all the jobs in the background, you can use the jobs command, and that pretty much sums it. So now we'll just see a small exercise so that we can understand it better. I'll just stop all the jobs in the background by bringing them to foreground first and then stopping them. So it's being brought to foreground. I'll just press Ctrl C to stop. Then again jobs. Then I'll bring it to foreground again, FG %2. Then again Ctrl C to stop. Now if I do jobs, there should not be anything, right? Now let's do a small exercise. We can just create it like this. Yeah, Vim bash. I'm using Vim. If you have any editor called gedit or something, you can use that. I'll just use Vim. You can also see this for the tutorial. I'll just create a bash script, and in that I will just do Vim bash. This line tells that this is a bash script, so execute as a bash script. And I will just do a while loop, while true do, and I will just append something, echo -n, oh yeah, into maybe this test output file, and then I'll wait for 1 second, then done. So what I'll just explain it in short. What this is a bash script, so it has different syntax. So we're starting the while loop, and we are echoing whatever, like this the dollar sign is basically the command prompt, and whatever you enter after the command prompt is taken by this @. So we are saying that echo whatever the user is sending to you, echo it into this output file, a file called output file, and then wait for 1 second, then again execute the loop. So let's just save this and let's just execute this. If you do ls, you will see the bash script is in normal text, so it's just a plain text now. Now if you remember from previous session, we have to for making it executable, you'll use the chmod command. I'll do the plus x, x stands for executable, so chmod plus x, then bash script. And yeah, now let's do ls. Now you can see it has turned green, so it's been executable. Now you just do /bash script to execute it, and with a name, maybe we'll just provide a name of anything random. So it's been executed. I'll just open another terminal and I will do ls. Then I will do, where is the file, the output file, you can see here. So I just do cat output file. You can see random is being like whatever you give here, it's being appended to the file. Now if you do again cat output, you will see there are more number of random because it's being currently executed. So if you want to see the file refreshing file, you can just use this tail -f. The -f shows that follow the file, like if it's being appended, just show the current file. So tail f output file, you can see the random is appended, then it waits for 1 second, then again random is appended, then waits for 1 second, then again random is appended. So what we can do is we'll just send this to foreground. So remember, we'll send this to background. So remember, to send a process from foreground to background, we just use Control Z. Now you'll see it stopped. If I do jobs, you can see it's being stopped. So if it's stopped, what your random should not be like printing anymore. You can see this has also stopped. Like the file do not have any more input of random. Now if you want to start the process in background, what you will do? You will do bg %1, the job number. Now you'll see it's been running in the background. So just keep a note of it. While it's been running on background, you can also work with any other commands in the foreground. So you'll see now the random will be implemented. Yeah, the random is being appended to the file with 1 second interval. And now you have the option to run any other command in the foreground. If you want to command again, you want to execute that bash script with another maybe argument, which you can say Linux. So in the background, you are running the bash script with random argument. In the foreground, you are running the script with Linux argument. Now your output should be the combination of both. Yeah, random Linux, random Linux, random Linux. Basically, this is the background, this is the foreground. So you can also stop this with pressing Control C, and this with also Control C. Now you just see, is there anything running on your background by using the jobs command. Now you have to stop it. How you'll stop it? You bring it to foreground, fg %1. Now you press Control C to stop it, then clear, then exit. So this was a small tutorial to show you the practical uses of like background and foreground jobs. Hope it was clear. And I'll just let Samrit take over the control.
Okay, so yeah, now Bileshwar has covered processes now. So you guys know how to start a process, move it to the foreground, background, everything. Now we are gonna move on to things which would be making processes on their own and running them, which are software. So any software you install is a process and it runs in the background, foreground, however, and now you guys can manage those processes. But how to install the software that is doing all that stuff, and how do you install them, remove them, search for them, list everything you have installed, all of them we're going to cover here. So first of all, we have to everything managing any package or software is done using a package manager. A package, it is a simple software and it's present in almost every Linux distribution. And as most of you guys are using Debian based systems like Ubuntu, Pop, Parrot, Kali, so you guys will be having APT, and if you're using an Arch based system, you would be having Pacman. Right now we only have commands for APT and Pacman here. We will add commands for other package managers later, but right now if you have these commands, you can follow along. So first of all, we have how to search for a package. So in this example, I'll be using a software called C-Matrix. If you guys know what C-Matrix is, it's a simple software to create a matrix-like effect, matrix as in the movie Matrix effect in the terminal. So you can appear cool in front of everyone. And so yeah, first of all, we need to search for the package. So the command for that is sudo apt search and then the name. So I can do that here. Sudo apt search matrix, and sudo requires a password. Here you can see by typing C matrix, apt shows that there is a package called C matrix by someone called Jamie, and it simulates the display from the matrix. So we know, okay, this is the this is the package I need to install. Now, if we need to install it, we need to do sudo. So as you guys know, sudo is super user do, which means we need to uh, execute this command as a super user, so it has all the admin privileges. So anytime you're using a command with sudo, make sure that you know what that thing is doing. Okay, do not run blindly, do not run anything blindly using sudo. It could literally break your system. So sudo apt is the software, install is an argument, and the name of the package is another argument. Yeah, now I'll try to install cmatrix. Sudo apt install cmatrix, and it will start installing it. So you can see it's telling you every step, all the progress, everything. Yeah, and now we should have cmatrix. But how do I verify if we have it or not? There's an option to list every package I have, so I can do that. Yeah, I have to listing all the list all the packages I have installed. I need to use sudo apt list. The switch is installed, so I can do that. Sudo apt list installed. So there are a lot of processes. So one thing I can do is I can write this command, and then I can grep C matrix from this. If you guys don't know what grep is, we'll come to that in another session. It's basically finding something in text. So if I do this, you can see now C matrix by Jamie has been installed in the system. So, and now all I need to do is run C matrix. So I will just do C matrix, and you can see my terminal is now a matrix system. Okay, I can see everything. So if you guys want to try along and do install anything that is on apt, first step is to do sudo apt search for the name. Then you can install it. Then you can see if you can verify it if it's installed, and then you can just use it however you want. And say you need to remove a package, you have to use sudo apt remove, then the package name. I'm not going to remove cmatrix because I use it sometimes. So these are the main steps while you are installing any package. And if you have used Windows, there are a lot of other steps. You need to go to a website, you need to search for the downloads page, you need to install an exe file, you have to install it, you have to click accept on 5 different licenses, and then you can run it. So in Linux, if anything is in an official package manager, in the repositories of the package manager, you can install it using one step. If you know the name, you don't even need to search for it. You can just do sudo apt install for the name, and you can simply install any package you want. And so, and one another thing, in Windows, if you know, upgrading and updating the system is a hassle. In Linux, that is also made very simple. You can use apt or the default package manager to update the entire system at once. It will update every package and any system stuff it needs to do, which is sudo apt update and sudo apt upgrade. So this and syntax, and basically means run this command, then run this command. So these are two separate commands, but we basically always run them together. So I just put them in one command. So sudo apt update and sudo apt upgrade -y. So sudo apt update means it's updating the repository, and basically there is a version of the repository online in the repository's site in the server, and there's a version of it on our machine. So what we are doing is we are basically updating our system's repositories according to the online one. So now when you do update, basically every latest your system knows which application has been changed. Say you maintain an application, a package, you make an update to it, you put that update in the apt repository, which is online somewhere. Okay. Now, when I do sudo apt update, the listing of the repositories in my system gets updated according to the online one. So my system now knows, okay, I have version 2, but version 3 has been released because I've updated it. And then you can do upgrade, which where upgrade means basically I need to basically download the newer versions which I need from the online repositories into my own system. So update and upgrade, and this dash y is to just say yes, I need to do it, because at one step it prompts you, do you really want to install this? And because I always say yes, I just put dash y there. So this flag tells it to just install everything. And I'm not going to do that now. I'll show you how to update it. You can press Q in CMatrix, sudo apt update. I just try the update part because upgrading takes time and takes data. So yeah, it tells me 20 packages can be upgraded, and it also tells us we can list the upgradable packages. Okay, and if you see, it's using the HTTP protocol. Basically, it's going to the internet and updating all the repositories. You can see, and it's building a dependency tree. Everything it does, it basically lists, it figures out which packages need to be installed and need to be upgraded. And because this is Linux, in the /lib folder there are common libraries. If a common library needs to be updated, it does that too. And if any package is using those libraries, and if a dependency changes, everything needs to be updated. So that is all done by in this step, building a dependency tree. And okay, so now we can see the upgradable items. So I'll do list upgradable. Now you can see it's basically qt5 git and qt. Okay, so these are the things that need to be updated. I'll do this later. And onto the pacman commands for this. If you're using Arch, I have listed the Arch pacman versions of all these commands over here. You can see them. And yeah, and in this website, if you press this button, you can directly copy the command in the code block, and you can put that in a terminal. Control-Shift-V to paste. So it's simple. So now we have covered the default package manager. Now we come to Flatpaks. Flatpak is basically another type of package manager, but what it does, it removes all the hassle of managing dependencies. So as we saw in APT, it makes a dependency tree. It manages dependencies according to the libraries which are installed in a system. In a Flatpak, basically everything the Flatpak needs is in the Flatpak. It basically has no other dependencies. So it can run anywhere, in any Linux distribution, in any kind of thing. If there are enough resources, it will run. So that's the beauty of Flatpaks. And to use Flatpaks, first of all, you need to install the Flatpak package. So you need to do that either through apt or through pacman. But after you install it, you can basically start using it. And yeah, so first of all, Flatpaks also need online repositories. So as apt, we update the repositories. We need to add a repository to properly use it, and that repository is FlatHub. It's a website which basically hosts every Flatpak you will ever need. So it's very important. So you can copy the command from here. After installing Flatpak, you just add a remote to Flatpak, which is FlatHub. And after adding the FlatHub repo, you can basically see whatever you need. You can basically see the commands, see the packages in FlatHub and install them. And I'll go through some basic commands here. First of all is listing packages. So I can do Flatpak list app and see all the Flatpaks that are installed in my system. You can see there's Obsidian, there's Discord, there's Teams for Linux, a lot of stuff. And all of these are, as I said, all of their dependencies are stored inside them, so they do not need anything external. And with a Flatpak, you notice two things: the name of the package of the Flatpak and the application ID. This application ID, basically, this is the unique identifier of any package, of any Flatpak, and this is what you use to delete packages or anything like that. So here you can see I have Pepis installed, and I don't really use Pepis, so I will show you how to uninstall it. So yeah, to uninstall it, there is Flatpak uninstall remote. This, I don't think remote needs to be here. It's a mistake on my part. Flatpak uninstall name. I will update this. So if I do Flatpak uninstall, so to uninstall it, Pepis is here, but we need the ID of Pepis. So dev.lukebriggs.pepis. It's saying me these two things will be uninstalled, and uninstallation is complete. And if I do Flatpak list app, you can see Pepis is gone. Okay, so Flatpaks are very simple. They are very simple to use. Updating them is very easy. Using them is very easy. Installing everything is very easy. And as opposed to APT, there's no dependency problems. And there are a lot of apps which are not available in APT in any repository, but they are available in as a Flatpak on FlatHub. So these are the two main package managers you need to know: the default one and Flatpaks. Yeah, I'm done here.
So basically this concludes our session 2. Hope it was useful for you guys. Hope you enjoyed it. Just let us know if you have any issues. Else, all the best. Just try installing Linux, and we will meet in the next session. We will just learn